Forgotten the laws of logarithm? Please watch the previous videos. In this video, we will talk about the logarithm worksheet. So in question 1a, we have an equation where we are supposed to solve it. And just remember that whenever you have solved, it means that your answer should be x is equal to something. Or you can have two answers actually, or three, depending on the question itself. So using the law of logarithms, I can combine the left hand side to form just one logarithm. Basically, I'm going to multiply x minus 1 with x minus 4. The reason why I can do this is because the bases are the same. So that is equal to my right hand side, which is log base 2x minus 6. Now I notice that I have one equation on the left, one logarithm on the left hand side. I also have one logarithm on the right hand side. Similarly, both of my bases are 2. What that means is that in the next equation, I can actually remove the logarithm. I can just have x minus 1 multiplied with x minus 4 is equal to 2x minus 6. Expand and simplify this, followed by factorization or quadratic equation. That will give me my values of x. So it seems like I got my answers. But do remember something. We need to consider whether our values fit the range. Based on the different questions that we have went through, we see that the range of x can differ from logarithm to logarithm. So back to the question, we have log base 2. Okay, 2 is a positive number, so we don't need to consider that. But we do have x minus 1, and x minus 1 has to be positive, more than 0. So what that means is that x has to be more than 1. Okay, that's for the first logarithm. What about the second logarithm? We have x minus 4 to be more than 0. What that means is actually x is more than 4. Okay, and then lastly we have 2x minus 6 to be more than 0. That is basically 2x is more than 6 and x is more than 3. So if you combine all of these inequalities, x more than 1, x more than 4, x more than 3, what that means is basically x has to be more than 4. So let's check. X more than 5, this is alright. Sorry, x equal to 5, that is alright because it's more than 4. But then x equal to 2 won't be accepted. So we have to reject this. We would have to reject this. And our reason would be that x is more than 4. That's all. Next, in question 1b, we are also supposed to solve an equation. And we notice that our bases are the same. So what I'm going to do is I'm going to manipulate this equation to have log something equal to log something. Then I can simplify from that. So on the left hand side, I can combine the two logarithms to give me log base 3, 2 multiplied with x plus 4. And on the right hand side, we have multiply by 2, which is basically just log base 3x squared. Do take note that this square is for x and just x. Then I have log equal to log. So next step, I can remove the log. This is what I have. Expand and simplify, I get a quadratic equation. I can either factorize or use the quadratic formula to find my values of x. And then lastly, check if those values of x are within the range of what x is supposed to be. So I have my two answers. I see that 3 is more than 0, 2 is also more than 0. X plus 4, if this is more than 0, it means that x is more than negative 4. And over here, I have x to be more than 0. So if I combine all these inequalities together, I see that my range is basically just x has to be more than 0. So therefore, I'm going to reject x to be equal to negative 2 because x is more than 0. In question 1c, I have log minus log equal to a number. So there are a few ways to do this. This method 1, I'm going to simplify my left hand side first. Then since I have log minus log, that is basically just division. So log minus log, I have 8 squared divided by 4. This is equal to 2. So this will then give me, and using the idea of the relationship between logarithm and exponents, I'm going to rewrite this as p squared is equal to 16. That will then give me p to be equal to plus minus the square root of 16, which is basically just plus minus 4. So since p can be positive 4 or negative 4, we also got to check whether they fit the range or not. So based on the definition of logarithm, we know that the base has to be more than 0. So in this case, we have p to be more than 0, and we reject the one that is not more than 0. So as mentioned just now, this here is method 1 because there can be many different ways to solve a logarithmic question. In question 1D, similarly you identify that the bases are all 2. So you just need to simplify the left hand side, keep the right hand side as it is. Basically you have log equal to log, and then you can remove the log in the next step. So for math, it is essential to show all working. You can't just skip from like this step to this step. You can't just do that. You need to show me the logarithm on both sides first before getting to that step. So expand, simplify from your quadratic equation. Use either factorization or the quadratic formula to find your values of x, and then check if your values of x matches the range. So x plus 1 has to be more than 0, x has to be more than negative 1, x minus 2 more than 0, meaning that x has to be more than positive 2, 3x minus 5 more than 0, x has to be more than 5 over 3. Essentially, x has to be more than 2. So therefore we reject this because x is more than 2.